All right, welcome back to Mr. P Helps with Algebra. This is Unit 2, Topic 3, Lesson 5, which is on the substitution method of solving a system of equations. We're not actually going to be doing Lesson 5. We're going to be doing something that I substituted for that lesson. Yeah, I know, bad joke, substitution method. We're going to start off with an inequality warm-up. So we've got a line which happens to be the same thing as this equation right here. That's called the boundary line. So that's 1/5 x minus 4, and the reason I know that is because -4 is the starting point, and for every 1 up, it goes 5 right, because that's the slope. Up 1, right 5. It's positive. It's going up. So this equation is the same as this line. Now, I'm going to test the theory of, I'm going to be shading, let's see, it says less than, so typically when it's less than, we shade underneath the boundary line. So let's test that theory by putting 0, 0 in for x and y. So if y was 0, and that is less than or equal to 1/5 times 0, because that's what x is, minus 4. So that means 0 is less than or equal to 1/5 times 0 is 0, minus 4. 0 is not less than -4, which means this point and any other point that's above the boundary line would not be a solution. And we have just proved that the other side is the solution, so it would look like that. All right, so I'm going to do the same thing over here, put 0, 0 in for x and y, because I don't have to choose 0, 0. I'm just choosing that because that's an easy number to put in, because it's easy to solve. 0 is less than or equal, greater than or equal to -3 times 0 plus 5, because anything times 0 is 0. That's what makes it so easy. So 0 plus 5 makes 5. 0 is not greater than 5, so that's not true. So it's got to be the other side that is shaded. All right. And it would include the boundary line. I know we haven't seen any examples of this, but if it was just greater than, then the boundary line would need to be a dotted line and not a solid line, meaning it can't be equal to. So that boundary line would not be an answer. All right, so let's get to this substituted lesson for this, on substitution method. So we are going to be solving we're going to be solving equations by using what's called the substitution method. This is one way of solving a system of equations. It's actually one of my, I think it's probably my favorite way of them. But because it always works. That's the reason why I like it so much. So it's substitution method because I'm going to take this and I'm going to substitute it in for y. If y equals 2, then I can plug that in for y and solve. So 2 times x plus 8 times 2, because we now know y is 2, equals 20. When I solve that, I get 2x plus 16 equals 20. Subtract 16 from both sides. And that tells me that 2x equals 4, which means x must be 2. Now, once I know one variable, I can just plug it in typically and find the other variable, but I don't need to do that because y was given to us in the equation. So we know we know that 2, 2 is going to be the only place where these two equations meet. It's this 2 because x is 2, and it's this 2 because y is 2. Now, I'm just going to do half of these problems because question 1 and 2 happen to be the exact same, so let's skip down to number 3. So now we've got a little more than just a number for y, so we're going to take 2x, plug it in for y. 5 times x minus 2 times 2x, because that's what y is. We're going to take this and plug it right there, equals 3. So that means 5x minus 4x equals 3. Well, that's easy because that's going to leave us with 1x. 5 minus 4 is just 1, and 1x is just x. So that means x must be 3. Now, as I mentioned up here, we're going to now take our answer, plug it back into one of the equations, and solve for y. Now, I'm choosing to use the bottom equation because it's smaller. It's going to be easier to do. You can actually choose whichever one you want. 2 times x is now 3, which means y must be 6. So the answer is 3, 6. These are two linear lines that will cross each other, and the only place they're going to cross each other is at 3, 6. Okay, number 5. This time we've got a little bit larger expression that y is equal to, so we're going to plug that in for y right here. So 4x plus 7 times x plus 9, because that's the value of y, equals 19. So now we use the distributive property. Whenever you solve an equation, you distribute, combine like terms, and then do opposite operations. 7 times x is 7x. 7 times 9 is 63. Both positive, equals 19. Now it's just a matter of combining like terms, which is 11x and then do opposite operations to solve for x. Subtract 63 from both sides, which 19 minus 63, I believe, is negative 44. Divide both by 11, and x must be negative 4. Once I found negative 4, plug it back in. The bottom one looks easier. Y equals negative 4 plus 9, so y must be 5. Okay, on to number 7. I'm going to, actually, you know what, I'm going to do 8 because it's x equals. I'm going to take this top line and plug it in right here. So that's 3 times 2y minus 1 minus 2y equals negative 3. So now we distribute. So we've got 6y minus 3. Don't forget about the second one. A lot of people will just put the minus 1 down, but it's 3 times this and 3 times this. Bring down the minus 2y because we didn't do anything with that. It was not in the parentheses. If it was, then you would have had to multiply the 3 by it if it was inside the parentheses. Combine like terms. 6y's minus 2y's makes 4y's. Bring down the minus 3. Add 3 to both sides, and you get 4y equals 0. Divide both sides by 0. I'm sorry, divide both sides by 4. Can't divide by 0. Means y has to be 0. Because 0 divided by 4 is 0. Now I can take that, plug it back in. Top equation, x equals 2 times 0 minus 1. 2 times 0 is 0. 0 minus 1 is negative 1. So the solution here was negative 1, 0. Once again, we've got two linear lines that will intersect each other, and the only place they do is at negative 1, 0. All right, so now we've got 9 and 10. So now we've got a little bit trickier because we're not given anything. We're not given x equals or y equals. Since we're not given anything, we have to solve for one of the variables. Now, it would be easiest, you don't have to, solve for one of the variables without a leading coefficient. If you try to solve for this y, you're going to end up having to do 2 steps. You have to get rid of the x, and you have to get rid of the 3 by dividing both sides. So I'm going to try to stay away from this one, and I'm going to choose one of the others. It really doesn't matter which one you do. I'm going to do the top one. So let's say I solve for x. I do that by getting rid of the y. Subtract y from both sides, which means x equals 3 minus y. If I subtract y here, I have to subtract y on this side because that's the subtraction property of equality. I cross that off because I don't need it anymore. I'm going to take this and I'm going to substitute it right there. So we've got 3y plus 3 minus y, that's what I substituted, equals 5. All right, so there's nothing to distribute there because there's just a plus sign. We can say, well, keep that the same, keep that the same. So it's really a 1 on the outside, but there's no reason to do that. So that's going to be, let me get rid of that, 3y minus 1y, that combined like terms makes 2y plus 3 equals 5. Subtract 3 from both sides makes this 2, and then divide both sides by 2 and you get 1. Plug the 1 back in just like we've done in the past. 1 plus x equals 3. Subtract 1 from both sides means x must be 2. So we've got 2, 1 is the clear answer. All right, now, the only thing that makes this a challenge problem is the fact that it's not going to be too easy to solve for x or y because they all have leading coefficients. Me personally, probably the way I would have done this problem, because I've been doing this for quite a while, and I just instinctively know I'm going to look for common factors. 5, 10, and 15 can all be divided by 5. So if you divide all of those numbers by 5, that doesn't change anything because that's division property equality. And that is going to make your x a single x, which would make it one more step in order to solve for x by adding 2y to both sides. So you end up getting, this line is going to turn into x equals 2y plus 3. Because this turned into x minus 2y equals 3. And I divide that by 5, that by 5, and that by 5. And then I added 2y to both sides and got this. So that's gone, and that's gone. Now you can simply take this and substitute it right there. Okay. If my memory serves me right, I believe you get decimals for both x and y in this equation. So if you decide to keep going, please keep that in mind. Homework. All right, I'm going to do these one at a time. We're given a boundary line, and we're told that the bottom half is the shaded part. So the first thing I'm going to do is focus on the boundary line. So y is, I'm not going to write greater than or less than right now. I'm going to leave that till the end. The boundary line has a y-intercept of 7, so it's going to be plus 7 at the end, and it's got a slope that looks like it's going down 1, right 1, down 1, right 1, down 1, right 1. Down 1, right 1 is a slope of -1. So negative 1x plus 7 is the boundary line. Now, the boundary line is solid, so it's going to be or equal to. It's not a dotted line, and it's shaded below, which means everything below or less than that boundary line. This represents the boundary line. This represents the answer. So the answer is going to be below or less than the boundary line. All right, I'm going to erase that because I do want you to watch the video. I don't want you just to skip to the very end and see the answers. Here we go. This time we're going to do the same thing. So y represents the answer. -4 is the y-intercept, and it's going up to right 1, up to right 1. Up to right 1 is a slope of 2x. Because it's rise over run. It rises 2, runs 1 to the right. Both positive. Up is positive, right is positive. All right, so then boundary line is solid, so it's or equal to. And this time, everything that is above the line is the answer. So that means the answer is greater than or equal to 2x minus 4. All right, thank you again for watching. I hope you are able to understand substitution method. Please give it a like if it helped you learn something, and subscribe if you haven't done so already. Thanks again for watching. I know it was a pretty long video. All right, have a great